I am the virtual teacher at Egnatia Career College. Today we'll teach HVAC and plumbing drawings, electrical drawings. This is video number 10. HVAC and plumbing drawings. After completing this unit, you will be able to perform the following tasks. Identify and briefly describe the major pieces of HVAC equipment to be used in a building. List the sizes of pipes and fittings shown on mechanical plans, and explain the major functions of each. Describe the sizes and shapes of air handling ducts shown on mechanical drawings. Introduction. Heating, ventilating, air conditioning, and plumbing are often referred to as the mechanical systems. For residential construction, these systems are rarely covered in depth with drawings. The subcontractors who will install these systems can do most of the work with the very minimal information shown on the floor plans. If additional drawings are necessary, those subcontractors will prepare their own. In commercial construction, however, such as the school addition, the mechanical systems are more complex and the drawing set usually includes drawings for HVAC, heating, ventilating, and air conditioning, and for plumbing. The original school addition drawings include 2 plumbing drawings, identified by the P prefix in the sheet number, and 5 HVAC drawings, identified by an H prefix. The school addition drawings included in your textbook contain only 1 plumbing drawing and 1 HVAC drawing. Heating, ventilating, and air conditioning plans. The HVAC system for a building larger than a single-family house is designed by an engineer who specializes in this work. The drawings for this work are usually drawn on a basic outline of the floor plan for the building. This allows the mechanical drawings to show where HVAC and plumbing equipment is located in relation to rooms, walls, floors, and so on. The coordination of structural, mechanical, and electrical work is often an issue of some concern on construction projects, and so it is important to understand where and how pipes will pass between beams or through walls. Most commercial buildings are heated by burning fuel, natural gas or fuel oil, and distributing the resulting heat in the form of warm air, hot water, or steam. Warm air heating systems require ducts throughout the building to carry the warm air to the occupied spaces and to return the cool air to the source. A warm air system has the advantage of allowing for inexpensive air conditioning. The same ducts can be used to distribute either warm air in winter or cool air in summer. The ducts, however, require much more space in ceilings and walls and are harder to route through and between structural elements than are pipes. When hot water or steam is used to transport the heat to the occupied space, 2 pipes are required, one to supply the hot water or steam and one to return the cooler medium to its source. The basic type of system is readily apparent to anyone looking at the HVAC plans. The plans for an air handling system include ductwork. The plans for a hydronic system include more pipes and fittings. Unit ventilators. At first look, the heating plans for the school addition might appear foreign and difficult to understand, but like most of the drawings you have studied before this point, these drawings are easy to understand when taken one step at a time. Notice that each of the rooms in the addition has a rectangle on the outside wall with a call-out of UV1, UV2, or something similar. These indicate that this building is heated by unit ventilators. The figure is the schedule of unit ventilators. In the actual drawing package, it was H7 on sheet H4. A unit ventilator is a unit that combines a means of mixing room air and outside air to ventilate the room while also warming it. The warmth is provided by the hot water that is piped in from the boiler. This figure explains the principles of a unit ventilator. The heating controls include a function that controls the balance of recirculated inside air and fresh outside air. During the day, when the building is in use, the damper is open to allow more fresh air to be circulated through the room. At night, the damper is closed, so that less cool air enters the room, resulting in an energy savings. The amount of air that is drawn in from the outside when the dampers are closed as much as possible is indicated on the drawings and on the schedule as CFM, cubic feet per minute. Other information on the schedule of unit ventilators describes such things as the total amount of air that passes through the unit, the water temperature intended by the designer, and the speed of the fan. This school does not include air conditioning. If it did, the unit ventilators would be supplied with cold water when cooling is called for. The same system of balancing inside and outside air would be used for energy conservation and fresh air, but instead of passing the air over heated pipes, it would be passed over cold pipes. The schedule of unit ventilators would include information for air conditioning. The unit ventilators are only a few feet long. Yet the plans show a continuous string of equipment of some sort along the exterior walls of the classrooms. Although not labeled anywhere on the plans, the equipment is bookcases. The construction notes refer to them. The manufacturers of unit ventilators also manufacture bookcases and filler pieces that are designed to fit with the ventilators and fill the rest of the wall space. These bookcases have a false back, with space for pipes to and from the ventilators. In some spaces, such as stairways and storage closets, the heaters are not labeled as UV unit ventilators. These are cabinet unit heaters, CUH, that mount on the surface of the wall and do not have ventilation capability, and fan coil units, FCU, that are intended to provide more heat than ventilation. This figure shows the schedules for the units marked as CUH, UH, and FCU. Heating piping. Once the basic type of heating system has been determined, the next step is to understand the piping that carries water to and from the heating units. It is easy to spot the pipes on the heating plan. A solid line indicates supply pipes, and a dashed line indicates return pipes. Pipe sizes are indicated by callouts throughout the plans. Fittings such as valves, elbows, and T's are represented by symbols. This figure shows the most common symbols for mechanical systems. There are standard piping symbols, but each drafter uses a few special representations of his or her own, so a symbol legend is included with the drawings. Pipes are easier than ducts to coordinate with structural elements because the direction of the pipe can be changed easily and frequently. Pipes might run horizontally in a ceiling for some distance, then loop around a column and drop down to a unit ventilator. It is not practical to show the layout of all pipes with separate plan and riser views. The common method for showing pipes where both horizontal and vertical layout is involved is to use isometric schematics. Plumbing isometrics are discussed in Unit 35. Sheet H1 of the School Edition drawings combines plan views and isometric schematics. The long runs of pipes are shown in plan view to indicate where the pipes are in relation to the walls. Where the pipes need to drop down from the ceiling to the level of the ventilators, they are shown in isometric views. For the sake of explanation, the following discussion traces the hot water supply piping, broken line, in room 109, the storage room on the first floor, E7 on sheet H1. Most of what is discussed here is also shown in this figure, but we will start closer to the center of the building, where the branch tees to the right, north, off the main supply running from top to bottom of the drawing. See the symbol legend A11 on sheet H1 to interpret the symbols as you trace the piping. It is recommended that you use a colored pencil to trace the piping as you read this. The first thing we encounter is a valve, an elbow toward the top of the drawing, and then another elbow back to the right. Construction note 13 indicates that the pipes pass through a structural steel member. The line is broken for clarity through the area where ductwork is shown that would make reading the piping drawing difficult. Pick the line up again in the storage room 109. Next we come to a T where the pipe drops down to the level of the unit ventilator. If we continued on to the right or north, we would come to construction note 2, which tells us that the symbol indicates a riser to the second floor. The riser is not shown in the wall, where it would actually be positioned, because doing so would bury the riser symbol in the wall with material symbols and other lines. The pipe going down is actually shown at an angle up and to the right. This is the isometric portion of the drawing. At the level of the unit ventilators, the pipes are arranged in a special way to eliminate noises that might result from expansion and contraction as the water temperature changes. The ends of the pipes are shown with break lines, which indicate that the pipes actually continue to their obvious destinations, fittings on the unit ventilators. Air handling equipment. The unit ventilators introduce fresh air into the school addition. A separate ventilation system removes stale air from each room of the school. All the rooms in the addition except the smallest closets and the stairways are provided with a system of ducts and a fan to ensure air circulation. A louvered grill in the room receives the air and channels it into a duct that carries it to the roof, where a fan exhausts it to the outside. This figure explains the designations for outlet and inlet grills. The ducts that carry the air to the roof vent are shown by their outlines and do not indicate their sizes. A square or rectangle with a diagonal line through it indicates where the duct rises to the next floor or the roof. Several notes indicate that ducts rise up to EF- on the roof. EF is an abbreviation for exhaust fan. The number indicates which of the several exhaust fans on the roof the duct is connected to. Some of the exhaust fans occupy several square feet of space on the roof, so they cannot be placed too close together. Trace the flow of air as it is exhausted from the janitor's closet on the first floor. The path starts with a louver marked RB, return, 8x6, cross-sectional size in inches, 75 cubic feet per minute nominal airflow. Between the janitor's closet and the storage room, the air enters a 6x6 duct, which goes up through a chase, space between two walls, to the second floor. At the second floor it is joined by the exhaust air from the second floor janitor's closet. On the second floor plan there is also a symbol indicating a fire damper designated as W access door at floor. This damper, metal gate, closes off the duct if it gets hot in a fire. This is necessary because the building code requires fire-rated construction, and an open duct is a great place for fire to spread. The access door at the floor allows for maintenance and repairs to the damper. Notes at both levels indicate that the duct between floors is 6x6. Above the second floor louver, the duct is 8x8, and at the second floor ceiling, it is offset an unspecified distance into the storage room, where it turns up to EF4 on the roof. The reason for the offset is because it would otherwise be too close to the other duct such that there would not be enough room for both exhaust fans on the roof. Plumbing. The plumbing for the school addition consists of DWV drainage, waste, and vent, piping to remove effluent, wastewater, hot and cold water distribution, and fixtures. The DWV system is more complex for a building this size than for a house, because the large flat roof collects quite a bit of water in a rainstorm and there must be a way to get rid of it. Therefore, the second floor plumbing plan shows roof drains, marked RD, and storm drain piping, indicated by a heavy line. Call-outs along the storm drain indicate the size of the pipe and its slope and give information about how the storm drain is to be coordinated with structural components of the building. On the first floor plumbing plan, the storm drain is represented by a heavy dashed line, indicating that it is below grade. Notice that the storm drain and the sanitary drain are separate systems. The storm drain only needs to carry rainwater away from the building. The sanitary drain must connect to a sewer or septic system. Although the storm drain and the sanitary drain pipes cross near the janitor's closet on the first floor, they are not connected. In the region where this building was constructed, drainage pipes outside the building lines are installed by the site contractor, not the plumbing contractor. Therefore, the plumbing drawings only show the storm drain and sanitary drain to a 0.5 feet outside the building lines. A note where each line passes through the building wall indicates the invert elevation of the bottom of the inside of the pipe. The hot and cold water piping is similar to that found in homes, except that the hot water is a two-pipe system. A return hot water pipe allows the hot water to circulate continuously, ensuring that hot water is readily available at the point of use. The hot water supply and hot water return can be distinguished from each other by the number of short dashes in the symbol. These are explained on the symbol legend in the drawing packet. The hot water return, which is usually smaller than the supply, maintains circulation to a point close to where most of the hot water will be used. It is often not practical to continue a hot water return pipe to every fixture in an area with several fixtures like the school addition toilet rooms. The figure shows riser diagrams for the fixture connections in the school addition. A riser diagram shows the vertical arrangement of the piping. Notice that there is no hot water return shown on these diagrams, because the return is connected to the supply before the supply reaches the first fixture. A plumbing riser diagram is only used to indicate design intent and does not indicate a piping route. The sizes indicated by the engineer are minimum sizes. Company preferences and local codes can dictate that larger sizes be used. Notice that riser 1 and riser 4 in this figure are identical. This does not mean that they will always be installed the same way. The notes on riser 1 are different from the notes on riser 4. The notes on both risers are relevant for risers 1 and 4, and the vacuum breakers required on S1 in riser 1 are also required on S1 fixtures in riser 4. The note to route all piping in the casework in riser 4 is also relevant for the piping in riser 1. It is important for plumbers to know and comply with local codes. In riser 3, the vent serving MB1 is offset 90 degrees below the fixture. That is an illegal installation by most codes, and the plumber would install the vent pipe in accordance with local codes and not use the riser diagram as a guide for routing the pipe. Where the pipes seem to connect, but are actually different piping systems, you can outline the pipe route with different color pencils to clarify the different piping systems. Electrical drawings. After completing this unit, you will be able to perform the following tasks. Explain the information found on a lighting plan. List the equipment served by an individual branch circuit using electrical plans, riser drawings, and schedules. Explain the information on a schematic diagram. Electrical drawings deal predominantly with circuits. Knowledge and understanding of the basic circuits used in buildings is necessary for those working with and interpreting electrical drawings. The 4 basic methods of showing electrical circuits are plan views, single-line diagrams, riser diagrams, schematic diagrams. Plan views. The electrical floor plan of a building shows all the exterior walls, interior partitions, windows, doors, stairs, cabinets, and so on, along with the location of the electrical items and their circuitry. Power circuits. The power circuit electrical floor plan shows electrical outlets and devices and includes duplex outlets, specialty outlets, telephone, fire alarm, and the like. The conventional method of showing power circuits is to use long dash lines when specified to be installed in the slab or underground, and to use solid lines when concealed in ceilings and walls. Short dash lines indicate exposed wiring. Solid lines are often used in commercial installations when the raceway conduit is to be exposed, surface mounted. Slash marks through the circuit lines are used to indicate the number of conductors. Full slash marks are the circuit conductors, a longer full slash is the neutral, and half slash marks are the ground wires. When only 2 wires are required, no slash marks are used. The typical wire size for commercial construction is number 12 AWG, American wire gauge. The arrows indicate home runs to the designated panel. The panel and circuit number designations are adjacent to the arrowheads. This figure lists the typical circuiting symbols. The electrical installer will normally group home runs in a raceway with combinations similar to the following: 3-phase systems with 3 circuit wires and a common neutral in a raceway. Single-phase systems with 2 circuit wires and a common neutral in a raceway. Note: to reduce the harmonic problems caused by solid-state devices, nonlinear loads, many electrical designers are requiring separate neutrals with each phase conductor. Some equipment, such as television, fire alarm, clock, PA, and sound, might not be connected with wiring lines on the plan. This indicates that wiring for that equipment is not part of the general circuit wiring and is probably not to be fed through the same panels as the rest of the electrical equipment. For example, on the school edition, the PA system and the clocks are fed from the sound system console and do not involve the general circuit wiring. Lighting circuits. There is usually a lighting circuit electrical floor plan for each level or major space within a building. This floor plan shows light fixtures, emergency lighting, security lighting, and special lighting control, photocell, motion detector, etc. Typically included is a reflected ceiling plan. That is, it is a plan view but shows what is on the ceiling as though it were reflected onto the floor plan. The reflected ceiling plan shows each light fixture with a circle, square, or rectangle that approximates the shape of the fixture. The lighting circuitry on the school edition is shown with 3 types of wiring circuit lines: solid for unswitched, dotted for switched, and line-line for the motion sensor circuits. The conventional method of showing lighting circuits is the same as previously explained in the paragraph above on power circuits. Motion sensors are an interesting feature of the lighting design for the school edition. The motion sensors are shown as small circles containing the letter M. A motion sensor detects any movement in the area of the sensor. So that in a room controlled by a motion sensor, if there is no movement in the room for a period of time, the sensor opens its contacts, like turning a switch off. A motion detector can be used together with a switch, so that the lights are controlled normally by the switch. But if someone forgets to turn the lights off, the motion detector will. A low-voltage lighting control system requires a relay that is activated by the light switch. The relay opens or closes the higher voltage fixture. The relays on the school edition are indicated by the letter R in a small square. Notice that every lighting switch is connected to a relay. Symbols. Electrical symbols are used to simplify the drafting and later the interpreting of the drawings. Electrical symbols are not standardized throughout the industry. Most drawings have a symbol legend or list. You must be knowledgeable of the symbols specifically used on each project, since designers modify basic symbols to suit their own needs. Many symbols are similar: circle, square, etc. The addition of a line, dot, shading, letters, numbers, and so forth gives the specific meaning to the symbol. Learning the basic form of the various symbols is the best starting point in developing the ability to interpret the drawings and the irrelated symbol meanings. This figure shows common electrical symbols and abbreviations. The school edition drawing E1, symbol legend A4, contains an electrical symbol list for the project. From the symbol list, it can be seen that there are duplex receptacles, switches, telephone outlets, special purpose outlets, and fire alarm devices mounted at various heights. Then there is the general note in the symbol legend that specifies that all mounting heights are to be verified and modified as directed. This is an example of why the installer must become familiar with the drawings and specifications far in advance of the scheduled time for the installation. The installer must request clarification or direction and give the designers reasonable time to clarify the questionable specified instructions. Single-line diagrams. The electrical service single-line diagram on the school edition is shown on drawing E2. Single-line diagram E17. The electric power is brought into the school by way of the service entrance section, SES. The note coordinate with the local utility requirements prior to rough-in indicates that the electrical contractor is to furnish and install the 3 4-inch conduits, and that the utility company wants to inspect the conduit installation prior to backfilling the trench where the conduits are installed. However, this should be verified at a pre-construction meeting with the utility company. There are times when an electrical service or electrical distribution raceway would require being concrete encased for protection. This type of concrete encased underground raceway system is called a duct bank. The note does not specifically indicate who furnishes and installs the utility feeders in the 3 4-inch conduits. This could be an expensive item and should be clarified with the utility company prior to estimating and bidding the project. To comply with the National Electrical Code, the service entrance section may have up to, but must not exceed, 6 main disconnecting units, switches or circuit breakers. For main fused switches are shown in the existing portion of the single-line drawing. Note that this single-line drawing shows only a portion of the complete existing service entrance section. The service entrance section indicates that it is located outside by the NEMA 3R enclosure. National Electric Manufacturers Association, NEMA, generates specifications that are recognized as design standards for electrical boxes, devices, and equipment. NEMA 3R is a rain-tight designation. The new portion of the single-line drawing shows the electrical distribution to be installed in this school edition. The feeders for the new elevator, electrical panels L10. and L11 are fed from existing panel MDP. These new electrical loads are 60 amp circuit breaker with 4 number 4 AWG, 1 number 10 ground, and 1 number 10 isolated ground in a 1/4 inch conduit feeding the elevator. 100 amp circuit breaker with 4 number 1 AWG and 1 number 6 ground in a 1/2 inch conduit feeding panel L11. 100 amp circuit breaker with 4 number 1 AWG and 1 number 6 ground in a 1/4 inch conduit feeding panel L10. A complete building electrical floor plan is not a part of the school edition drawings. And the existing electrical distribution plan on drawing E2 shows only a portion of the total electrical distribution section. This required notes 6, 7, and 8 to be added to drawing E2. Single line diagram E17, giving the contractor the lengths of the feeders for the elevator, panels L10 and L11, which are to be included in this school edition. In a typical design, a complete building electrical plan is provided indicating the locations of all existing and new electrical equipment. The feeder length would be determined from that drawing. Riser diagrams. A riser diagram is so named because it usually shows the path of wiring or raceway from one level of a building to another, and because the wiring rises from one floor to the next. A riser diagram does not give information about where equipment is to be located in a room or area. Riser diagrams are used because they are particularly easy to understand and do not require much explanation. A power riser diagram shows a typical building's electrical service and related components. This figure is not the same electrical service as the school edition single line diagram, E-17, on drawing E-2. But comparing the two diagrams shows how a power riser diagram greatly simplifies the interpretation of an installation drawing. A special riser diagram is used for many systems that include fire alarm, security, telephone, clock, signal, bell, call, nurse, emergency, etc. Water sprinkler. The fire alarm riser diagram shows the new school edition fire alarm system with 3/4 inch conduits to ramp area 113. The school edition drawing E2 shows 3 3/4 inch conduits with the note 3/4 inch existing conduits from the fire alarm control panel, 150 feet. These 3 conduits are to be used for the school edition fire alarm connection to the existing fire alarm system. The original fire alarm control panel was sized to accommodate this school edition. However, you should verify that the existing special systems, fire alarm, security, clock, etc., will accommodate the additional requirements when adding to or modifying the existing systems. The telephone riser diagram shows an existing 1/4 inch conduit, 150 feet in length, from ramp area 113 to the existing main telephone terminal cabinet. This conduit is to be extended to the telephone terminal board in room 102. First floor plan E7. Drawing E2. The telephone riser diagram shows telephone conduit to be installed in the area above the suspended ceiling from the telephone terminal board to the outlet locations, as shown on drawing E2 and outlet detail A11. Schematic diagrams. A schematic wiring diagram is a drawing that uses symbols and lines to show how the parts of an electrical assembly or unit are connected. A schematic does not necessarily show where parts are actually located, but it does explain how to make electrical connections. Several of the schematics with the school edition show connections to wires labeled G, N, and H. These stand for ground, neutral, and hot. Schematics are commonly drawn for electrical equipment that involves internal wiring, everything from washing machines to computers. A basic motor control schematic shows a 3-phase power source, L1, L2, and L3, through the starter contacts, M, and the overloads, OL, powering the motor. The starter control is taken from phase L1 through a stop push button, a start push button paralleled with a latching contact M to the starter coil M, and finally through the normally closed overload contacts back to phase L2. The connection label numbers 1, 2, 3, etc., which are shown on the schematic, aid the electrician in troubleshooting. Several different labeling methods are used. but they all follow the same principles. So if you understand one method, you can understand the other methods. Schedules. An electrical schedule is used to systematically list equipment, loads, devices, and information. Schedules organize the information in an easily understood form and can be a valuable method for communicating the design requirements to contractors and their installers. The fixture schedule lists complete information about each fixture type shown on the lighting plan. The following is a list of the kind of information that is usually shown on a fixture schedule. Mark the label used to indicate a fixture type. The mark is written on or next to each fixture on the plan. Make the identification of the manufacturer being used to establish the specific design requirements needed to aesthetically and functionally light the various rooms or areas. Volts. It is becoming increasingly common for light fixtures to be powered by up to 277/480 volts. While the switches might use only 24 volts, low voltage lighting control, to protect the person using the switch. Watts. It is necessary to know the wattage of the lamps, bulbs, in each fixture, so that the space will have the amount of illumination intended by the electrical designer. The School Edition Fixture Schedule A9. Floor Plans E7 and E14 on drawing E1 shows type FA light fixture to be the light source for the classrooms. The remarks column indicates some special wiring and specific wiring and specific ballast type requirements. The first and second floor reflected ceiling plans E15 and E16 on drawing E7 indicate light fixture type FA to be a 2 foot by 4 foot light fixture mounted end to end. 15 other light fixture types are shown on the fixture schedule and on the drawings, and are identified by their corresponding mark or label. All are rated at 120 volts except one emergency battery-powered remote lamp, rated at 12 volts. This information is typically given in the specifications, but is more readily presented by a schedule. A panel schedule identifies the panels by their mark or label. They are shown by this same designation on the electrical floor plan. The panel schedule for the School Edition lists each of the branch circuits served by a panel, the calculated load for that branch circuit, the voltage of that circuit, and the number of poles and trip rating for each circuit breaker. A panel schedule also might include type, surface or flush, panel main bus amperes, volts, and phases, main circuit breaker / main lugs only, breaker frame sizes, items fed and or remarks. On the lighting and power plans, we saw that each device is connected to a branch circuit identified by a panel number label and circuit number. Those numbers correspond with the numbers on the panel schedule. When a commercial project has a kitchen, you should have a kitchen equipment schedule. If the drawings do not have one, it is very helpful to make one for the installer. The kitchen equipment schedule should include equipment number or designation, description of each equipment item, the load in horsepower or kilowatts, volts, wire size, conduit size, protection in amperes, who will furnish each equipment item, furnished by others or by contractor. Installation requirements. Remarks column for any detailed specific information required. A receptacle schedule is valuable when a number of special or specific receptacle types are found on the electrical drawings. If one is not provided, you should make one to expedite the installation time required and reduce the chance of installation error. A receptacle schedule should include the symbol designation used by the designer, amperage rating, number of wires and poles, voltage rating, NEMA type, the configuration of the blades or slots, a manufacturer catalog number reference, special information, duplex, single, three-phase, etc. Note: receptacle information may be found on an equipment schedule. The local plans review and the utility company typically require a connected load schedule. This type of schedule includes type of load, building or area designation, size of load, kilowatts or horsepower, total electrical load by type or area. Notes explaining any special methods used in the load calculations. Lamp type and quantity. Lamp manufacturers have similar systems of designating lamp characteristics. This figure shows how to read product information. It is about compact fluorescent lamp designations. Part 2 shows different type of compact fluorescent lamps. Specifications. The drawings and the specifications are the items that establish the intended design and the construction requirements required by the owner. The contractors and their installers must review the contract documents for conflicts and/or discrepancies between the contract, the specifications, and the drawings. The drawings should be reviewed for conflicts between sections. Architectural, mechanical, plumbing, structural, civil, HVAC, electrical, etc. The drawings in your specific section should be reviewed for conflicts sheet by sheet. The electrical specifications give the quality of materials intended to be used and the installation and testing requirements. Sometimes a specific manufacturer or catalog number is specified with no substitution or equal allowed. This usually inflates the cost of the project. There is no standard specification. The contractors and their installers should read through all project specifications and become knowledgeable of their content prior to starting any installation.